running just a couple minutes late here. Apologies for that. Scrambling a bit to try and find funding so that I continue to have a job and a role in the public climate science communicating space. As I mentioned before, a bit of a cliff coming up this summer and still no solutions necessarily, so a little bit frustrating, but thanks for bearing with me. I've been having some more meetings. We'll see what happens. Still looking for large philanthropic funders or perhaps high wealth individuals who are interested in this. I think we've sort of come down to that because we've exhausted all our other potential funding options for highly public facing climate science in this moment. It has been an uphill battle and it continues to be uphill. So anyway, that's not really what I wanted to talk about today. Let's talk about the weather instead. Much more interesting, right? And the pattern is interesting. California has been once again doing something very different than the rest of the country over the past few weeks. Where California, it's been relatively cool the last week or so, but nothing extraordinary, whereas it has been genuinely extremely cold across much of continental North America, especially mid-continent, center part of North America, central Canada, and Central U.S., but also in the Pacific Northwest as well, where there have been some really terrible damage from ice storms, something that California generally does not see, but does occasionally occur under the right conditions up in Portland and Western Washington, and boy, have they been hit hard in recent days. So I want to talk about all of that, as well as what's coming up in California, with some rather wet conditions this weekend into early next week, although not particularly cold conditions, and this has significant implications for what is going to happen to the snowpack. And then we've got also a question about what's going to happen as we round out January and head into February, sort of these peak winter water and snow accumulating months in California and much of the West, amid our kind of weird but still strong El Nino year. What does it all mean? Where are we headed? Let's talk about all of that today. So what I wanted to start with was the really cold air mass that we've seen in recent days across the center part of North America. Here in Boulder, it was extremely cold over the weekend and the early part of this week, where temperatures dropped well below minus 10, getting down to around minus 20 for a couple of days, and didn't get above 0 degrees Fahrenheit across a lot of the Great Plains for a few days. That's pretty cold even by the standards of these parts, and although it's manageable because the infrastructure in this part of the world is designed for it to occasionally be extremely cold. One place where it is not necessarily very convenient to have extreme cold is the Pacific Northwest. So really, the far southwest coast of British Columbia, including the city of Vancouver, southward to the western valleys of central Oregon, where depending on where you were, you either saw a major snowstorm, a major ice storm, potentially both, or not much of anything and just cold and dry. So Seattle did not get a big snowstorm out of this one, but Vancouver, British Columbia saw one of its largest snowstorms on record, almost 10 inches of snow just yesterday alone. And Portland, Oregon, and especially some of the areas to the south and west of Portland, a little bit closer to the coast and south in the valley there, saw a major ice storm with over half an inch of ice accumulation in some places. And again, an ice storm is something that I think folks who have never experienced one don't necessarily know what it is. This is not the same thing as a hailstorm where balls of ice fall from the sky. They can occasionally accumulate, but that's not an ice storm. It's also different from sleet, which again is a different form of frozen small little particles of ice that accumulates, if you're lucky, kind of like snow or just melts on the ground. But an ice storm is what happens when liquid rain falls from the sky onto sub-freezing surfaces. So essentially everything gets coated in a solid, clear layer of ice. And in some cases it can be a really dramatic amount of ice. Even just a tenth of an inch of freezing drizzle can make it almost impossible to walk outside on a sidewalk or drive a vehicle on a road because every single surface is just glazed with a near frictionless surface. But once you start getting up into 3, 4, 5/10 of an inch, half an inch of freezing rain, as occurred in parts of Oregon earlier this week, you start to get major damage because that's a huge amount of water that just sticks to trees. If you have snow, usually it tends to fall off of branches and off of power lines once it gets heavy enough. But if it's freezing rain, it just continues to stick and continues to accumulate until things break. Power lines, tree branches, all sorts of damage. It's a real mess, and you can't drive anywhere and you can't walk anywhere. So it genuinely is one of the most disruptive types of weather, I think. Doesn't happen really except under really weird local conditions in some of the highest valleys, mountain valleys of California. It's really not a California thing. It does occasionally, as I mentioned, happen in the Pacific Northwest. Clearly, it happened earlier this week. And it does occasionally happen sometimes in the Mid-South. So in places that are actually south of California but east of the Rockies that are occasionally susceptible to cold air outbreaks where there's really cold air aloft, where you might still have the Gulf of Mexico influence, keeping temperatures just above the surface, just above freezing, so that the falling precipitation melts, falls as rain, but then once again the surface is cold enough for it to refreeze into a glazing. So be glad that California doesn't get that kind of weather, because it has all of the hazards of the cold, icy world without any of the benefits of having the nice weather. So that's just not a nice, fluffy snow, but it's a pretty miserable type of frozen landscape. So anyway, the Pacific Northwest was hit hard. It was very cold. Some of even the inland portions of Puget Sound even started to freeze over a little bit, which is, again, not unheard of, but definitely unusual. And it's kind of a mess up there in the Pacific Northwest. Very cold in the Central U.S., but not as cold as the extreme Arctic outbreak a couple of years ago that caused the crisis, the energy crisis in Texas that ultimately led to the death of probably over 1,000 people who literally froze to death in their homes in Texas a couple of years back. Fortunately, this was not on that magnitude. But it just goes to show you that even in a warming climate, you definitely can see extreme cold outbreaks. And one of the interesting things, and by the way, this has been wrong in many media headlines this week, there isn't really evidence, in fact there's evidence very much to the contrary, that cold events, extreme Arctic outbreaks in most of the world are becoming, well, less extreme and less frequent, as you would expect as temperatures overall get warmer and as the Arctic warms, the source region for all of these cold air outbreaks, 3 or 4 times as fast as the rest of the world. So the place where all of the Arctic air has to come from in the first place is warming faster than almost anywhere else. However, there are 2 interesting, I hesitate to call them exceptions to that, but at least deviations from that expectation maybe is more appropriate, where in the Central U.S. and parts of Central Eurasia, the cold extremes that we're seeing are not getting warmer, even though overall those same places are seeing temperatures overall that are warmer, and we're seeing fewer of these Arctic outbreaks. But when they occur in those 2 particular locations, in the Central U.S., so the Great Plains, and in Central Eurasia, they're just as cold as they were 100 years ago. So what that means is that in practice, they feel even more extreme than they would in a climate that wasn't getting warmer overall, because they're an even larger deviation from the otherwise warming winter temperatures. So it's not really the case that in a warming world we're getting hotter hots and colder colds. One of those is true, and one of them isn't. But there are these 2 regional differences where the colds aren't necessarily warming as fast as the warms. And that is a bit of a regional peculiarity that we don't fully understand yet. And it's possible that there are reasons linked to the way that weather patterns are changing in the Arctic that is producing, say, this unusual effect where the really cold Arctic cold outbreaks in those particular regions are not warming as much as we thought they might. But it's not making them colder. And the reality is even these places are still warming dramatically. And so is this something that's going to continue, or is this something that's eventually just going to go away? Is this kind of just random chance, or is this actually being caused by something that's persistent? I honestly don't think the science is there yet, and there is some evidence pointing in both directions. So, do I think it's correct to say that the Arctic is causing more extreme cold outbreaks, even in these places? No, and that has been a headline that I think is just factually erroneous, that we've seen in recent weeks, and we've seen it in recent years too. But is it also true that there might be something weird going on in the Central U.S. and in Central Eurasia similarly, as a result of climate change, where the really cold outbreaks are not warming as fast as we thought they might? Certainly not as fast as the rest of the year or the cold extremes in other places. Yes, I do think that's plausible, and there's some interesting scientific questions there, as well as some real-world impacts, because again, if the world is warming all around you, but the very coldest cold outbreaks are still as cold as they ever were, then you have to really plan and adapt for a much wider range of temperatures, and that is actually pretty difficult, and part of the reason why the Texas power grid had such extreme difficulty during that extreme event. I believe it was, I'm already losing track, in early 2021. So anyway, a secondary blast of Arctic air is now sweeping down the plains, but this is a more ordinary one, something that we would typically see a couple times every year, so not really newsworthy. But the reason I mention it is there's going to be a dramatic pattern shift across all of North America once again. So out of the freezer and back into the frying pan over the next 7 to 10 days. It doesn't necessarily mean it's going to be dry and warm, but it sure is going to be warm. And in California, that's going to mean wet and warm initially, and then even warmer, and then maybe a bit drier after that. So what's going to happen, and I'm actually going to show some graphics in a moment, is that the Pacific jet is going to extend all the way across the Pacific Basin once again, and essentially surge some warm and moist air across all of continental North America, getting rid of all of that dry, cold Arctic air that's been sitting around for the past week, and that's going to rapidly be history. In fact, some places may go from seeing daily record lows to daily or even monthly record highs over the span of just a week. So some of the places that were literally 20 degrees below zero in recent weeks could easily be well above freezing, and maybe even seeing genuine t-shirt weather within a week or so. And even in places that are accustomed to large temperature swings, that's a pretty big deal. Now in California and the West, this warm surge of air is actually going to be accompanied by some significant storm activity that could cause, especially in regions that just saw a bunch of low elevation snowfall and freezing temperatures, some enhanced flooding, because these are going to be relatively warm storms falling on top of some significant low elevation snow accumulations up in Oregon and Washington and British Columbia. So expect elevated flood risk even beyond what the amount of precipitation might normally connote up in those regions, because again, it's going to be falling on places that have seen a bunch of lower elevation snow recently, which is remarkable because those same places until very recently were experiencing snow drought conditions up in the Pacific Northwest. Very warm conditions up to the present, a sudden, quite extreme Arctic outbreak up in that part of the country, and now followed once again by wet and very warm, very mild conditions. Down in California, these systems are going to come through starting later on Friday and over the weekend into early next week. There's going to be 2 or 3 distinct systems, it looks like right now. None of them look extreme, but at least 1 or 2 of them look moderate to strong in some places, and this may end up being one of the wetter systems of the season so far in much of Southern California. So these will make it to Southern California, unlike a lot of recent systems. Now, they are going to be relatively warm, not extremely warm systems, but they will have a subtropical moisture connection, so that'll boost rainfall totals, but also raise snow levels. And I think for most of this storm, snow levels are likely to be above 7,000 feet. They may briefly get down to around Lake Tahoe level, but for the most part, it looks like the snow accumulation is going to be above 7,000, maybe even up above 7,500 feet. So that's pretty high. There could be a couple of feet of really heavy, wet snow accumulation up above the snow line, but there may actually be a net loss of snowpack in some of the lower elevation regions that have seen some light to moderate snowfall recently. So it's not totally clear that this is really going to bolster snowpack very much, which is on a statewide average right now, right around 50% of average for the date. So it is very low still. It's not as extremely low as it was a few weeks ago, but now that we're getting into mid-late January, it's also more meaningful. So it's 50% of a larger number, meaning that to catch up that 50% starts to get a little bit harder this time of the year. This, again, this upcoming storm sequence is definitely going to inject some much needed water, but it might not fall as snow consistently below 7,000 feet, and so that may limit the amount of accumulated snow water equivalent improvement, or SWE, that occurs. We might get up as high as 55 to 60% of average for the date, but I don't think we're going to get much past there with the storm sequence, and it might really be closer to a net wash, and we end up still around 50% of average as we gain snowpack at the highest elevations and maybe lose some at the lower elevations. And that's particularly true because after the storm sequence tapers off toward the middle of next week, the warmer conditions are going to continue, but then it's going to get drier once again as ridging builds in on the sort of the eastern edge of this jet extension. So warmer and wetter initially, and then just warmer and drier after that. Warmer being the key word, and potentially very warm. By the time we get to late January, there's strong multi-model ensemble agreement. The temperatures will be many degrees above average in California and indeed across almost all of North America. So certainly some whiplash going on with that over the next couple of weeks. By the way, I thought I'd mention to folks I am going to be participating in the Operation Sierra Storm Conference that starts this weekend. So I will be in South Lake Tahoe for that, talking with folks. You may see me on your local or not so local news channel. They tend to do a lot of on-site interviews, so you may see the Lake Tahoe backdrop. I guess I'll be reporting back on exactly what that Monday and Tuesday snow level is, because I might be standing out there on the lakeshore, potentially getting wet rather than getting snowed on. But we'll see. I'll root for snow levels to be about 1,000 feet lower than they currently look like they will be, but I'm packing rain gear. Let's just put it that way. All right, so I want to bring up some images. And let's see, you're going to see my camera disappear. You may see just in the transition, there may be an ad or something. Then you'll see my camera disappear, and then you're going to see some weather graphics pop up on screen. So bear with me for just a moment, please. Apologies, it may just be taking just a moment here to get it going. All right, I think what you're seeing, great. So what you're seeing now is the Tropical Tidbits website. This is a nice weather graphics website. It's run by one Dr. Levi Cohen. So I think he has a Patreon if you want to support him. I use these graphics a lot because they're well plotted and very accessible. It is a free website, by the way, so you feel free to check it out. All right, so let me see here. Just got to pull up the right screen on my end so I can do some on. All right. So this is a map from the American model, the GFS ensemble, showing the 250 millibar winds, both from the present and projected out all the way to the end of this model cycle, which is about 16 days in the future. And again, this is an ensemble average, so this is the average across dozens of individual model members that make up the broader ensemble. And what you'll see is, if I advance this forward in time, as you see, this is actually the present, so it went back in time a little bit. Right now, as you can see, this nice juicy jet extension. It's got a little bit of waviness to it, but it is extending all the way from southern Japan to the coast, just a few hundred miles west of California. So this is going to be the precursor to the major storm sequence this weekend. As you can see, this does continue to make progress towards the coast and essentially makes it to the California coast between Sunday and Monday. So all of that jet energy will help spin up some storms. It's not necessarily the most favorable configuration for big storms in California. So you may notice that the jet stream is bowed in this direction. This is known as anticyclonic curvature because if you follow it, it actually is part of rotation in this clockwise direction, which is in the northern hemisphere anticyclonic, meaning high pressure. So we do get the advantage of having this strong jet stream here, and we are on the right side of the jet in the sense that we are on the cyclonic shear side of the jet, but unfortunately the curvature of the jet itself is not the best for generating really big storms. We would want to sort of be in this position, for example, in the cyclonically curved portion of the cyclonically curved jet for the best potential for really robust storm development. As you can see, that doesn't really happen during the storm cycle. It kind of, we sort of have this anticyclonic wave break here, and then we sort of end up, the jet starts to retract a bit back across the Pacific. So there's still a decent jet signal even 2 weeks out as we go towards the end of January, but it's not really making it all the way to California. Now, what does this look like in terms of ridging versus troughing? Well, you see the weekend storms come in nicely into California. The persistent storminess starting at Friday through about Tuesday or Wednesday next week. But then you see that ridging building in really west coast wide and getting actually pretty strong for this time of year across much of North America. So you can see all of that cold air and that Arctic trough being replaced by big ridging across really most of continental North America that lasts for a while, really through the end of January in this model run and potentially beyond, depending where we are. Something similar with temperature that will become really apparent. We're already starting out. These are 5-day averages. So right now, this is including the present period where it's still really cold over the center of the U.S., but it's starting to warm up across the Southwest. We advance this forward in time, and that cold Arctic air goes away completely across the U.S., and things get really, really warm, especially in the eastern U.S. This is a really amazing transition from extreme cold to extreme warmth, but also no slouches, this huge area of warm air now all the way over western United States and western Canada. So all of that cold Arctic pool of air up in BC and Alberta, that is long gone by the time we get to the end of January. And then California actually gets warmer and warmer still in the southwest as we head towards late January and early February. Again, looking back at the large-scale pattern, that's not surprising, given that we have a pretty robust transport of warm subtropical air into the region. Now, the interesting thing here, if we do look at the anomaly in atmospheric water vapor and the column average, is it does stay relatively high over California during this period. So very, very warm by late January and early February, not necessarily dry, and there are some early signals potentially of wetter conditions developing again as we head into February. Now, sort of precipitation-wise, again, right now, look, we've got a nice wet cycle through across most of California over the next 5 or 6 days or so. That fades away as that ridging builds in, drier than average conditions once again. This goes through about February 3rd. I would not be too surprised if by February 5th or 6th, though, this area of enhanced atmospheric river subtropical moisture activity makes it further eastward into California. And if we look at the European model, that cycle isn't done yet, but we just look a little bit further out. In that model, there's an indication that this does start to move a little bit closer to the coast, along with another major jet extension sort of toward early February. That would potentially coincide with another favorable phase of the Magellan oscillation of the MJO. This is pretty far out. The modeling hasn't been great this year, but I do think that there's to be some good rain over the next week, albeit relatively warm rain, so maybe not a good snowpack accumulating situation. Then very warm and dry conditions to round out the month, and then continued warm and maybe wetter again by early February. That's currently what I'm seeing anyway. All right, let me see. I'll leave that screen up for a moment while I take a look to see if there are questions. Let's see. Relative to the map. I'm going to turn the map off and go back to the ability for everyone to see me. All right. All right, so I am back. Oh, I see. The screen is slightly off kilter. Just need to fix that. Bear with me for one moment. There we go. All right. All right, so I'm going to take a sip of tea and start looking at the questions. All right. Question from Marty, or a comment from Marty Walters. Your discussion last week about how the cold air doesn't tend to move into Southern California was so interesting. Gave us a great perspective on this last week. Thanks for that, and be grateful that geography is the way that it is. It is really genuinely very hard to get true Arctic outbreaks in California, and it's getting even harder. So even the really extreme ones we've seen across the Central U.S. in recent years have not been that extreme in California. It's gotten cold for sure, but nothing compared to what we've seen multiple times in recent years in the center of the country and even into the Pacific Northwest on a couple of occasions. Question from Jack. Looking beyond the CFS and European model weeklies have positive anomalies, I'm guessing, regarding precipitation for all of February, in contrast with the NMME. Has my outlook changed? Well, I mean, the seasonal predictive outlook, there isn't, in the most recent update cycle, a very strong tilt in any direction. I still tend to think that the ability of the strong El Nino to exert some forcing conditioned on the MJO and other oscillations being in the right phase is still with us, although probably starting to weaken. But then again, the seasonality of the background conditions that facilitate those interactions are peaking right around now. So if we do get a favorable MJO cycle in February, which is looking increasingly like we might, then there's no reason that February couldn't really be a blockbuster month. It could be very wet. In fact, this has been consistent with what I've been saying, with the likelihood of a back-weighted winter really since the autumn. Now, it's not a high confidence prediction because everything is kind of weird this year, and I do tend to think that these blobs of unusually warm water everywhere in the world right now, in addition to the tropics, are really messing up the relationship between El Nino and precipitation patterns. On the other hand, that underlying El Nino relationship is still there in those periods where there are favorable atmospheric conditions to align the background seasonal scale forcing with the subseasonal forcing. So that might yet happen in February, and I've been telling folks all along to not count out this winter in December, which is really before the main effects of what we've been talking about all along would even really emerge. January hasn't been an exceptionally wet month, but it also hasn't been an exceptionally dry month either. Many parts of California are likely to end January now with near to above average precipitation after all of this. So if that happens, and if we end up also seeing a wet February, then lo and behold, our winter probably ends up wetter than average overall, and that original seasonal prediction comes to fruition. It is worth noting that there's not a lot of confidence in that. I still think that there's a reasonably good chance that happens, but it could also end up being dry because California has missed out, despite favorable jet extension periods, on really wet conditions. So if that happens again in February, where that potential upcoming jet extension doesn't yield the goods, then that will be really telling. And at that point, I think it's going to be harder to recover and get a wetter than average winter. But if February's wet, January was wet enough that a wet February would probably get us to a wet winter overall. Now, snowpack is a completely different story, once again, because this is a really warm winter on average in many places so far, and it looks like we're about to go back into another really warm cycle. Wet, dry, whatever, it looks warm regardless in California. And so I think it's going to be really difficult to end up with a 100% or more of average snowpack year. I don't think that's going to happen, even if the winter ends up being wetter than average, because it's just too warm for that. Never say never, I guess. I mean, if you get a really good cold storm cycle at some point, then anything's possible. But I would definitely make a stronger prediction about a below average snowpack this year than I would about above or below average precipitation. I think that an average precipitation year likely gets us a below average snowpack, and maybe even above average precipitation year might still yield a below average snowpack because of how warm it is. No matter how much the folks at the Operation Sierra Storm next week might wish otherwise. At the top of the 10,000 foot chairlift, it might be a different story, but down at lake level, I don't know. We'll have to see about that. Well, that has been the theme for much of this winter, and increasingly, is the theme because the world is getting warmer. It doesn't mean it's never going to snow. It doesn't mean that we're not going to see these extreme snowfalls sometimes. I mean, last winter was like the opposite of this, right? It was just a consistently huge snow year everywhere in the West. But in most years, we are seeing the snow line creeping up the mountain. That is more representative of what's happening in the long run than not. So that's sort of what I foresee from that perspective. Bill Locke mentions that it got down to about minus 42 with a negative sign at his house in Bozeman, Montana during this outbreak. So it was a real one. Even for folks who are used to the cold, that's about as cold as it gets. Comment from Jasper. I'm new to Ohio. I'm assuming that's what OH means, but I've been reading for many years. Do you think well, maybe I'm wrong about the OH representing the state abbreviation for Ohio. In any case, do you think the NMME gets it wrong because ridges end up further west than it thinks? I think that's a difficult question. So this is a question about whether the errors in seasonal predictions, either recently or in general, are systematic. I tend to suspect that there are some systematic errors, and that some of these models tend to underestimate the persistence of existing ridges, or the potential longevity of ridging that they predict. I'm not so sure that it has a longitudinal bias consistently. But I do think that, this is something that can be quantified, right, in a study. So I really think to get a true answer to that, we'd actually have to look at it in a more formal setting quantitatively. But there are some areas where I think qualitatively it's pretty clear there are some systematic biases, but also that the biases are not quite systematic enough to clearly hedge against them. So sometimes those biases are present. So they might be conditional biases. Under certain circumstances, the models are preferentially wrong in a particular direction, but not in general. That's a good candidate, by the way, for machine learning informed approaches to sort of suss out whether there's a conditionality to it, and hopefully improve forecasts. So we'll have to see. There are definitely folks who work in that realm. We'll have to see what happens there. Yeah, Joanna Warrens points out that some people in Portland have been out without power since Saturday. That's a pretty long time if you're stuck at home and it's very cold. So it really is a mess up there. Let's see. A question from Doyle. Will it be warm enough next week for flooding in some parts of the country due to warming temps, snowmelt, and rainfall? Probably yes, at least in some areas. I haven't paid as much attention to the rest of the U.S. outside of the West, but this is likely to be true. When you get a warm air mass with some rain in it following major freezing or snowfall, then you do tend to get some flooding. I think that there is some flood risk along the West Coast too, particularly up in the Pacific Northwest, where it's been really cold and snowy and the ground is still frozen in some places, and where they're going to get a quick transition to warm rains. So these will be relatively significant rainfall events in their own right, and then the combination with those antecedent cold conditions could be a problem in some areas. Less so, I think, in California because there isn't a huge antecedent snowpack. So these warm storms, there will be some local flooding in Northern California and maybe locally in Southern California too, but that's more just by virtue of the fact that some locally heavy rainfall is possible, and the soils up in Northwestern California are actually pretty saturated. They've been quite wet along the North Coast in recent weeks, so there is some flood risk up there, and then some post-icy blast flood risk up in the Pacific Northwest especially west of the Cascades, or in the Cascades and west of the Cascades too, there may be some localized pockets of risk elsewhere where there's been significant recent snowfall. Let's see. It's a question from Eric about whether a weak or wobbly jet stream in the Arctic makes the punch through more likely in the north central U.S. I think this is referring to the sort of the blobby outbreak of these conspicuous very cold Arctic air masses spilling out into the more temperate middle latitudes. There is a relationship between the strength of the stratospheric and by extension tropospheric polar vortex, which by the way is a feature that's always there in winter. It's essentially a permanent feature of the Earth's climate system, so it's not some special thing that sometimes happens. But when the polar vortex is a bit weaker, essentially the openings in the fence can break. So you think of the west to east winds in the polar vortex, both at upper altitudes of the atmosphere and lower, sort of act as a fence keeping really cold Arctic air in the Arctic. And when that fence has gaps in it, when the jet stream either becomes weaker or wavier, it does tend to let these blobs of extremely cold air leak out, as we've seen in recent days. Now, the question is whether the jet stream in general, or the polar vortex, is actually getting wavier or weaker over time. And that's the problem. There's not a whole lot of evidence that that's actually happening. So we do know that weak states of the polar vortex are favorable for escapes of these giant Arctic air masses to much more temperate mid-latitude regions with all sorts of societal impacts and extreme weather. And it does look like in recent years we've seen some tendency for more of these weak polar vortex states than we did in decades previous. So this is complicated because the jet stream overall isn't getting wavier. This was a hypothesis, and the data just don't really support the fact that the jet stream is actually getting wavier. But are there other things going on? Are there increasing perturbations to the stratospheric polar vortex, and then sometimes that propagates down to the tropospheric polar vortex, where that fence maybe is a little bit weaker or more full of holes than it used to be? I think that's a plausible hypothesis that remains as yet uncertain, but it's possible. And so, in general, there is a relationship between the waviness of the flow at jet stream level, but there isn't necessarily a consistent indication that in winter that the jet stream is actually getting wavier. Now, there's a bit more evidence, ironically, that it is getting wavier in summer. So we're not really worried about Arctic outbreaks in summer, but then we're worried more about heat waves, and in some cases, in some places in the world, extreme precipitation events, because that's when they tend to happen in most parts of the world, is in the summer rather than the winter. And so there's some interesting evidence for what might be happening at other times of year, and there's still some uncertainty as to exactly what's happening in winter. So stay tuned on that one. I don't think that's going to be a topic in meteorology or climate science that's fully settled anytime soon. So there's a lot of active research going on there. All right here. Yeah, a few folks suggesting that there are some challenges with the audio levels. It is really difficult for whatever reason because I don't know if this is a YouTube thing or something that goes on when YouTube injects ads in the stream, but I have the same audio configurations, input and output, every time we chat. So do the best that I can. Hopefully, I do need to have it loud enough input-wise so that folks who have really weak speakers can crank it up. So you can always turn down the volumes, but if it's too quiet, sometimes it can be difficult for folks to hear at all. And I do have closed captioning enabled, so I think it should be real time. Let me know if for some reason that the real-time closed captioning is not available. I want to make sure that's available both for accessibility reasons and just because sometimes it's frankly easier to read if you're not getting the audio at the preferred quality. I don't know how much the auto captioning gets the technical details right, but generally I've become quite impressed with the auto closed captioning. I think it's actually surprisingly good compared to how it used to be. One of the more compelling AI advances actually in recent years, I would say. That's really genuinely constructive. A number of folks looking at or asking me to comment on the Euro weeklies and the potential for a very wet pattern in February. I mean, yes, that's definitely possible. It is important to realize that the weeklies, they aren't updated as frequently as other model cycles, so they tend to wave around a little bit more from run to run because there's a much larger separation in the initial condition between each run set. But yes, I mean, again, all the ingredients are there conditionally for really wet conditions in California this winter. It's just not clear whether the storm track is going to cooperate or not. And, the oceans are super warm. There's a lot of extra water vapor out there in the atmosphere. In fact, a record breaking. There's never been more global water vapor floating around out there than there is right now this year. So if a storm sequence is able to capitalize on that, then watch out, But there is still some question about whether that's actually going to materialize. If it does, there's a very good chance these will be very warm storms in February for the most part. So, there would be some increased flood risk with that relative to what happened last winter where we had very cold storms. Certainly, could see a scenario where there would be a lot of flooding and not much contribution to snowpack at all. In fact, you might lose net snow water equivalent. But really, in February right now, it's still a little bit too far out to be looking. But I would not be surprised if February was very wet. That is very much within the realm of possibility. And the other interesting thing, I've spoken with some folks at the Climate Prediction Center about this recently. There is a tendency sometimes for the seasonal predictive ensembles to make their best prediction a couple of months in advance and then sort of change their tune right before the month or the season in question in a way that ends up being not correct. This is kind of interesting behavior, and maybe it's suggestive of something that's in the initial conditions 2 or 3 months out that's actually either better initialized or more important for prediction than what's available immediately before. That's a bit of a hypothesis. It's not entirely clear what it would be, but we've seen this before. So it's possible that we end up very wet in February and then we end up meeting those earlier seasonal predictions of a wetter than average winter in Central and Southern California, despite the fact that the month before that happened, that the model ensembles trended much drier than they had been in the autumn for those same regions. If that does happen, it'll be kind of interesting to see why in retrospect. But again, that's another piece of quantitative analysis that's really difficult for me to do over the course of a YouTube conversation without looking at a lot more data. The earlier OH. That was not Ohio, it was office hours. Maybe that should have been obvious. Sorry about that. Comment from Jasper about the current Wikipedia article on the jet stream and how there's only mentioned the view that jet stream is weakening. Well, I mean, it's an interesting, Wikipedia. I think that I'm of two very divergent minds about Wikipedia. On the one hand, it's an unbelievable resource and I use it all the time. On the other hand, it is still something that is, some articles are incredible and then other articles are conspicuously weak and one-sided and not necessarily a balanced view that you might get from something that's a little better vetted. And it sometimes is really difficult to figure out in advance which is which. But I think part of this is because the news media coverage of the whole Arctic amplification and jet stream story has been quite bad. And I apologize to my many media contacts and partners who I really enjoy working with, but the coverage on this has just been quite poor, honestly. And there is, and it really stands out as something where there's this divergent coverage where there's a lot of, even this week, as I mentioned, there's news articles blaming global warming for the cold outbreak, which I think a lot of folks give quizzical looks to, and scientists do too, because they're like, well, okay, there's really just not evidence for this. But that then gets conflated with the notion that the Arctic doesn't matter and that there is no connection between the warming Arctic and changing weather patterns. And the truth appears to be somewhere in between. There's been some interesting work by pioneering scientists in this area. I mean, again, this is an incredibly active area of research, and it's also very contentious. So it's an interesting example, I think, of what happens when media, mass media picks up on something that is genuinely controversial scientifically, and then interviews only one or two people. Well, I think the challenge with this is that when you interview one or two people, there's a pretty good chance you're only going to get half of the picture. I mean, and I think that the challenge is that the science, is not totally clear on this. I don't think there's clearly evidence of absence of an effect. I actually tend to believe personally that there is some there, and that there is evidence for this. There are some studies that show tantalizing hints of connections between what's going on in the Arctic and mid-latitude weather. But also, there are other studies that show that a lot of the mechanisms that have been originally proposed are definitely not what's at work here. And that the notion that on average the jet stream is getting wavier just doesn't appear to be true. But on the other hand, as I mentioned, there do appear to be some other interesting things going on that are related to that initial hypothesis that changes in the pole to equator temperature gradient might be doing some wonky things in the world. And this is still true. There's the challenge is there's actually a tug of war where the rapidly warming Arctic is reducing the meridional or the latitudinal temperature differential at a certain level of the atmosphere, at the lower levels of the atmosphere, but that changes in the tropics, where at upper levels, the upper atmosphere is warming much faster than the rest of the world, are doing the opposite thing. So we have this condition where the atmosphere, the temperature differential near the surface is getting weaker due to Arctic amplification, but at the upper levels of the atmosphere is getting stronger due to this accelerated upper level tropical warming. So what happens in the middle, both vertically and latitudinally, is the big question. And this is something that a number of climate scientists have termed the Arctic tropical tug of war. Which of these wins out? It's not entirely clear. We don't actually know. If the Arctic wins out, then yeah, maybe some weird stuff is going to start to happen or is already starting to happen. But if the tropics win out, a whole different set of weird stuff might start to happen that completely overwhelms the weirdness from the Arctic. And what I personally tend to think is the more likely outcome is that this tug of war will vary over time and in space. So the answer will actually depend on which continent you're talking about, which ocean basin you're talking about, which season you're talking about, and which decade you're talking about. The tug of war, much like an actual game of tug of war, it can kind of go back and forth, and one team can pull the other team most of the way over, and then there can be a sudden turnaround. That's the nature of tug of wars, where you have two sort of opposing factors, pulling each other apart in opposite directions. Which side is stronger in a given moment depends on a number of factors. And one may win definitively in the long run, or it's kind of a stalemate indefinitely. That's sort of the way I think about this Arctic tropical tug of war, and I don't think that we have a clear picture yet. One of the really interesting things, though, and I haven't written this up formally scientifically, and there's only a couple of very vague hints to it in the research so far, is that the Arctic, the loss of Arctic sea ice in a lot of model simulations is really important for California winter precipitation. It's not 100% clear that this is real, but in the climate model world, this is really important. And interestingly, outside of the Arctic, the North Pacific west of California is one of the most strongly influenced regions by sea ice loss in the Arctic. This is kind of interesting, although it doesn't necessarily have the effect that you might expect. In fact, a lot of these climate model simulations now suggest that Arctic sea ice loss would make California considerably wetter in winter. Potentially accentuating the shoulder season drying, so the autumn and spring drying that we've talked about, but making winter wetter. And my own personal hypothesis is that in some of these simulations, part of the reason why California doesn't get drier on average in climate model simulations, as the rest of the Mediterranean climates on Earth do, of all the Mediterranean climates on Earth, by the way, California is the only one that doesn't get much drier on average in a warming world in the climate model simulations we use for the IPCC-like reports, for example, that might actually be thanks to Arctic sea ice loss, exciting a deepened Aleutian low in many years. So it's actually, in most of these modeling frameworks, not necessarily associated with ridging, but with enhanced troughing, with wetter conditions in winter in California during winter. Now, there is actually at least one study that directly contradicts that. It shows ridging instead of troughing. More of them show wetter California with more sea ice loss, but a couple of these models suggest drier California with sea ice loss. So again, just an illustration that I think this is yet another example of the tug of war. And we don't really know who's going to win, and there might be regional manifestations that are different than the global manifestations. And most importantly, it is very clear that the modeling tools we have right now, climate models, etc., are not adequate to address this question. We know for a fact they are not representing what's happening in the space in the real world adequately. And we don't really have any other tools to turn to. We can use observations, but ultimately we're limited. We only have a few decades of good observations of this, and sometimes there can be natural trends and variability that persist over decades. And so we can never really be sure if what we're seeing right now is due to global warming or is just something that would have happened randomly anyway. So I think this is going to be a really active topic of conversation indefinitely. We're not going to have a clear answer. Maybe as these models improve, we'll get a slightly better picture of what this tug of war looks like. But stay tuned, because this is really at the bleeding edge of climate science and atmospheric science in a warming world. Stay tuned. So I'm getting to the end of the hour. So let's see. Okay, there might be a manageable number of questions. Let's see if I can get through them. How long do I think it'll be for AI to start demonstrating value in forecasting? Well, again, I'm planning on having a dedicated office hour to that on the topic of AI and machine learning and weather and climate at some point soonish, TBD. Not quite sure when yet. But, I think in some ways it already is. There's all these splashy papers in Nature and Science about how these new these deep learning based models are in some ways comparable to or slightly outperforming existing models, but in other ways that are really important, they're not. Conspicuously, most of these still can't do anything with precipitation skillfully. So precipitation isn't one of the things that you can get out of a lot of these AI models right now, at least if you want it to be equivalent to or better than the benchmark. That gives me a little bit of pause, frankly, because precipitation is sort of the end result of a lot of complex physical and thermodynamic processes. And so if you can get some of the pieces right, but you can't get the end result right, I do wonder if the inner workings are sort of getting the right answers for the wrong reasons, in which case I'm not sure how generalizable this may be for the most extreme events or in the context of a warming climate. But on the other hand, there are some really compelling papers out there suggesting that the rate of advance in this modeling frameworks using artificial intelligence has been really remarkable, especially like the last 12 months. I can't keep up with it. And it's not really my job necessarily to keep up with it. I have a few too many jobs already. That's a story for another day, but it has been remarkable to watch this with just a foot very gradually in the door. And I do think that a lot of these teams, the big tech companies, would really be served better by having more domain experts involved, because just reading these papers, I can see really conspicuous gaps in evaluation metrics where, a meteorologist would say, like a computer scientist or a statistician might say, wow, this model's doing so well, the skill scores are through the roof. And a meteorologist might say, what the hell's going on with this? This is like non-physical, even though it's getting good skill scores. So I guess it's partly a question of what you've trained on. It's partly a question of what you're optimizing. Are you trying to build models to value the right things in the context of what actually matters in terms of weather or climate prediction? That's where I think a particular weakness of a lot of existing approaches might be. But in the long run, I think this is going to be transformative for the weather and climate communities. I don't think it is as transformative yet as some folks are claiming, but I do think we're going to get there. And already there's a lot of evidence of promise. So, I would not say that I'm a deep skeptic, but I'm a reasoned reasoned skeptic in the context of trust but verify. And so far, to the extent that I've been able to verify, there's some things that are being viewed through slightly rose-colored glasses. But again, long run, and in terms of hybridizing traditional physical models and AI-based models, I think that there is just a tremendous amount of promise there, and that it's really going to advance the fields of weather prediction. A little bit less clear that it's going to do so for climate science, but that's the next frontier, and I'm really curious to see how that evolves. I'll have a longer conversation about that later, though. Let's see. Steven says that for the live stream, closed captioning is unavailable. That should not be the case. It is standard for normally for live broadcasts, but it should be. I have explicitly set it to allow it though. So, let's see. Oh man. So maybe this is what's going on. Okay, I see that for some reason it. All right, that's the problem. It's defaulting to closed captioning off, so I think I have to actively turn it on for each session. I'll have to keep that in mind for the future. There are subtitles after the fact, by the way, no matter what, available, but they should be available live as well. That was my intent, so if I need to remember, I think once I've started the stream, I can't turn them on. I think that's the problem. So, next time. Thanks for that. All right. Well, thank you, everybody. This has been a really nice session. I'm going to try and keep it to the actual hour. My office hours often run a bit long, so I think this is exactly 60 minutes. So thanks, everybody, for joining. Enjoy the rain and maybe the snow if you're up high enough this weekend into next week, and then definitely looks warmer with drier conditions later in January, and then maybe still warm and then back to active conditions in February. Certainly looks like it's a possibility. So stay tuned, and thanks again for listening. See you next time.